Good morning. Wait, let me make sure I'm not muted. Okay, we're good. So I have the do now shared on the screen. So there are 5 questions, 1 through 4. You're looking at, will the solutes be more likely to dissolve in carbon tetrachloride, which is CCl4, or water? So I gave you a nonpolar solvent, CCl4 is nonpolar, and a polar solvent, which is water. And so what I want you to do for 1 through 4 is look at those solutes that I gave you and figure out, is it polar, nonpolar, or ionic? And what does that mean about what type of solvent it would dissolve in? All of the answers only have 1, so it's not like yesterday where you're check marking multiple. And then number 5 is actually reviewing chapter 11. So try these do now questions. We will go over the answers, so if you have to make any changes to your do now, you can. But go ahead and try, especially 1 through 4, because that's stuff that we covered yesterday. So take a couple minutes, try the do now, and then we will go over the answers in just a second. And then we will continue on with some solubility stuff today. So if you don't have your notes out, you want your notes as well. So take a couple minutes for the do now, and then we'll go over the answers. Okay, so if we look at the do now, again, when you're looking at creating solutions and you're looking at the solute versus the solvent, solubility is based on essentially the interactions between the solute and the solvent. So for number 1, you have C7H16. So C7H16 is a hydrocarbon, and so it's nonpolar. So if C7H16 is nonpolar, it's more likely to dissolve in a nonpolar solvent because they both only have dispersion forces as their strongest intermolecular force. And so that's why nonpolar solutes will dissolve in nonpolar solvents. So I'll just put the answer slide up while I talk through them. And again, you can double check and make sure that you have all of these on your do now sheet as well. So then for number 2, we had Na2SO4. So Na2SO4 is ionic. Remember, you always want to look at, is the solute polar, nonpolar, or ionic? So ionic is always an option. Sodium is a metal, which is why it's ionic. So ionic solutes dissolve in polar solvents. Think about NaCl. NaCl will dissolve in water. It's not as likely to dissolve in something like oil, which is a nonpolar solvent. And so for Na2SO4, it will dissolve in water. For number 3, HCl, so that's a polar substance, so it will dissolve in a polar solvent. HCl exhibits dipole-dipole forces. Yes, water will hydrogen bond, but in terms of HCl, it will just exhibit dipole-dipole forces with water. So then number 4, I2, that's nonpolar. So it will dissolve in the nonpolar solvent, which is CCl4. So 1 and 4 are CCl4, 2 and 3 are H2O. Now, you didn't have to write like all of this information. I just wanted to make sure that it was here on the slide in case you needed to go back and reference it at all. So like I said, number 5, I'm going to go back to the slide that has the question. Based on the table to the right, so this table up here, which of the following liquids has the weakest IMFs? Explain your answer using data from the table. So this is actually a question on the Chapter 11 quiz, and I know Chapter 11 seems like it was forever ago, but remember that Chapter 11 is still part of this unit. Unit 4 is Chapters 11, 12, and 13, which is why I'm trying to go back and review Chapter 11 as we go, which it helps that it's intermolecular forces. So when we're looking at this table, because it says explain your answer using data from the table, that means that we're looking at the values of vapor pressure. We're not looking at the substance itself. So we want to use the vapor pressures that are given to answer our question. So more than likely, we're looking at probably either the highest one or the lowest one if we're looking at intermolecular forces. So this wants to look at the weakest IMFs. So remember, when it comes to vapor pressure, let me grab this beaker. So when it comes to vapor pressure, we have a liquid, right? So pretend that there's a liquid in this beaker. we are focusing on the intermolecular forces of the liquid. Now, vapor pressure is the pressure that is exerted by the gas above the liquid. So vapor pressure is based on how much liquid has evaporated and become gas. So when it comes to intermolecular forces, really we're thinking about, is the liquid, is it easy to become a gas or is it more difficult to become a gas? So if we want weakest IMFs, that means that the IMFs are easy to overcome. So the liquid molecules, it's easy for them to become a gas. So we should be looking for the substance that has the highest vapor pressure. And so again, just kind of reading through the answer, the vapor pressure is the pressure that's exerted by the gas that exists up here above the liquid. The higher the vapor pressure, the more liquid has been converted to gas. So if it's easy for the liquid to overcome those IMFs, they're going to be weaker. If it's harder for the liquids to overcome the IMFs, they'll be stronger. So the C2H6O2, with such a small vapor pressure, it's really hard for the liquid molecules to overcome the IMFs. So C2H6O2 with the lowest vapor pressure actually has the strongest IMFs, and CH3OH, which is methanol, actually has the highest vapor pressure. So since CH3OH has the highest vapor pressure, it has the weakest intermolecular forces, since more of the liquid has been converted to a gas. So again, that's just kind of a quick review of vapor pressure, because remember that we looked at how everything is related back to intermolecular forces. And now with the solute and the solvent interactions for solutions, that's also going back to intermolecular forces as well. Before we get into anything for today, any questions on the do now? Let's see if anybody's. If you have any questions, remember you can always type it in the chat. Before we get into solubility curves, I just wanted to go over some questions from the video. And a lot of the questions were more specific questions. So I'm going to try to talk about everything in very broad terms, and then I'll try to get specific when needed. So as we continue to talk about solubility, remember that solubility is how much of a solute will dissolve in a given amount of solvent. So the solute is what gets dissolved. The solvent is what does the dissolving. For us, the universal solvent is water. So we use water as the solvent a majority of the time. In last night's video, solute-solvent interactions were again discussed. So remember, this looks at intermolecular forces between the solute and the solvent. And if you need to look back at video 11 from yesterday, that's where I made sure to add a lot of information about the solute-solvent interactions. But something to just keep in mind is that the stronger the attractions between the solute and the solvent, the more soluble the solute will be. So when you have something like ethanol and water, they both hydrogen bond. And so that's why ethanol is more soluble than something that is not able to hydrogen bond with water. So the ethanol ethane thiol question from yesterday talked about why ethanol is more soluble in water than ethane thiol, and that was because ethanol can hydrogen bond. So the stronger the attractions between the two, the more soluble it will be because they're able to interact more. When it comes to thinking about creating solutions, so let's think about creating hot chocolate. So you guys are sitting at home, still kind of cold out, and you want to make hot chocolate, right? Think about how you could ensure that the solute gets dissolved completely. So if we're thinking about, well, how can we make sure that the solute, whether it's a solid or a liquid or a gas, how can we ensure that that solute gets dissolved completely? And usually I have you guys in the lab for like 30 minutes figuring these things out, but not as easy from home. So think about with the hot chocolate, right? You could, well, it's called hot chocolate. So it needs to be hot, right? So temperature has an effect. And we're going to actually look at solubility curves today to see how, as we increase temperature, it increases solubility. And it actually goes back to the collisions. So almost thinking back to gases. So the more collisions there are, the faster the solute will dissolve. So when we have an increase in temperature, that results in a faster or a higher solubility. We can stir it, right? So the more that we stir it, the more collisions and the faster it dissolves. And we can actually, if you notice that hot chocolate is a powder, right? So we can crush something up into fine particles because that creates more surface area, more contact area between the solute and the solvent. And then we could also change pressure. Now this goes into the last bullet point. Henry's law was discussed in the video. And I gave you an equation for using Henry's law. I am not going to test on the math related to Henry's law. I'm not even going to test on what Henry's law is. I just want you to know that at a higher pressure, solubility increases. So that's why if you have a 2 liter, if I go and I buy a 2 liter of like ginger ale, when I take that lid off for the first time, you hear that like fizzing. That's because CO2 is pumped into the drink at a higher pressure. It increases the solubility. So you just need to know that at a higher pressure, solubility increases. So hopefully that helps to answer some of the questions that you had. There were some other questions like about mastering specifically. And so during work time, I can help to answer some of those more specific questions. So what we're going to do is we're going to go through pages 7 and 8 of the notes. So we're going to go through page 7 together. I'm going to actually get the document camera up. We're going to go through page 7 together, and then you'll actually do part of it on your own. And essentially what we're going to do is we're going to do this like almost like we were doing examples on the board. And so I'm going to do a couple together. I'm going to have you do a couple. We'll check answers, and we'll kind of keep going back and forth. As we go through, like always, if you have questions, you can type them in the chat. If you would rather, you know, your question be more anonymous and just I know, then you can send reminds. So what we're going to do for this, again, this is pages 7 and 8 in the notes. It says solubility and solubility curves at the top. A lot of this second video was on reading a solubility curve and what it means for a solution to be saturated or unsaturated or supersaturated. And it all goes back to these solubility curves. And so what we're going to do is we're going to look at different types of problems. Now, I will tell you that this is really just reading a graph. But sometimes the wording can be a little tricky. So I'll get a couple different colored pens to write with. So what we're going to do is we're going to go through a couple of these together, and then I'll have you do a couple on your own. So if we take a look at number 1. Number 1 says, what is the solubility of potassium nitrate in 100 grams of water at 80 degrees Celsius? Okay, so let's unpack this question a little bit. So I'm focusing on solubility of potassium nitrate. But then it says in 100 grams of water. Well, if we actually take a look at the solubility curve over here, the solubility curve says grams of solute dissolved in 100 grams of water. So by reading this graph, we are already looking at this 100 grams of water. So notice how in number 1, number 2, number 3, number 4, 5, they all are saying in 100 grams of water. That means just read the curve. So when it comes to looking at the solubility curve, essentially what these show is these solubility curves show the solubility. And for this, it's in 100 grams of H2O at different temperatures. So these solubility curves allow us to look at how much of a solid can be dissolved at different temperatures. So the y-axis is how many grams we can dissolve. The x-axis is temperature. And for this solubility curve, we actually just have three different substances. And I know it's a little blurry. It's very difficult to find some solubility curves. So when we're looking at solubility, we're looking at how much can be dissolved. We look at the line itself. So each of these lines represents a saturated solution of that solid. So it's exactly how much can be dissolved. So I want to find KNO3 at 80 degrees Celsius. So I'm going to follow 80 degrees Celsius all the way up to the KNO3 line. So if I zoom in a little bit more, 80 degrees Celsius, follow it all the way up to the KNO3 line, and then follow it over to the y-axis. I would say about 165 grams. So then we look for, in number 2, the solubility of potassium chloride at 50 degrees Celsius. Okay, so that means I'm going to go to the KCl line, but at 50 degrees Celsius. So here's 50. So try to read that curve. It's a little bit above 40. So maybe 41 or 42 grams. I would say one of either 41 or 42 would be accepted. So try number 3. What is the solubility of sodium chloride at 90 degrees Celsius? So follow 90 degrees up to NaCl. I like to put a mark on the line just to help me. So what would you guys read that to be if it's just under 40? Maybe 39? All right, so when it's asking about the solubility, you're just reading the graph. Right, so you're just going to read the graph. Now, number 4 and 5, we're getting into some different types of questions. So 4 says, what is the minimum temperature needed? So now we're looking at temperature. To dissolve 180 grams of KNO3 in 100 grams of water. So remember this in 100 grams of water is because that's what this curve is in. So the 100 grams of water to us really doesn't mean anything. It just means we can read the graph. But I want the minimum temperature needed to dissolve 180 grams of KNO3. So now I'm going to go to the y-axis of my curve. So here's 180 grams. And I'm going to follow it all the way over to the KNO3 line. And then go down to temperature. So notice I'm not on an exact temperature line. I'm kind of halfway between 80 and 90. So I would say 85 degrees Celsius. So needed to dissolve. Remember that these lines represent how much solute can be dissolved. So I want you to see if you can do 5 and 6. All right, so just 5 and 6. So take just a minute. 5 is going to be just like number 4. But then number 6, I want to know what temperature do KCl and KNO3 have the same solubility. So really I want to know where do the curves meet. So try 5 and 6. I'll do it up here as well, just not talking. Okay, so for 5 and 6, so for 5, minimum temperature, you can see I was marking on the curve over here. Minimum temperature needed to dissolve 35 grams of KCl. So make sure you're going to the correct curve. So follow 35 grams over until you hit the KCl curve. And it's right at about 30 degrees Celsius. And then number 6, at what temperature do they have the same solubility? So you want to know where the curves meet. Make sure that you're finding the correct 2 curves that meet. I was doing this earlier this morning and I started and I realized that I was meeting KNO3 and NaCl instead of KCl. So just make sure that you're meeting the correct curves and they meet right at about here. So I said 21 degrees. If you said 22 degrees Celsius, you'd probably be okay as well. Something just over 20. Okay, any questions so far? I don't see any in the chat. I haven't gotten any reminds, okay. So let's keep looking at this page. So number 7, if you dissolve KCl to its saturation point. So to its saturation point means to the curve. So that means that we've dissolved as much as the curve tells us to at 20 degrees Celsius. So before I even read on, I'm going to find KCl at 20 degrees Celsius. So 20 degrees, go up to KCl. So it's this one right here. So I would say maybe 32 degrees or 32 grams. And so the saturation point at 20 degrees Celsius is 32 grams. So I just wrote that down. How much more will dissolve if you increase the temperature to 90 degrees? Okay, so now I want to look at how much KCl could dissolve at 90 degrees. So I'm going to come over to 90, follow it up to KCl. So that's about, I would say about 52 grams. So if we look at what we've written down, we can dissolve 32 grams at 20 degrees Celsius. We can dissolve 52 grams at 90 degrees. The question says, how much more will dissolve? So to get from 32 to 52, 20 grams more will dissolve. So this is where we're reading the curve, but now we're applying things to the curve. We're applying the curve and we're looking at new conditions. We look at 8. If 50 grams of NaCl is mixed with 100 grams of water. So again, the 100 grams of water just means we can look right at the graph. 50 grams of NaCl at 80 degrees Celsius. How much will not dissolve? So let me look at 80 degrees Celsius. And I'm going to go to NaCl. 80 degrees NaCl. So at 80 degrees Celsius, I would say 39 grams of NaCl can dissolve. So at 80 degrees Celsius, based on the curve, I would say 39 grams can dissolve. So over here it says if 50 grams of NaCl is added, how much will not dissolve? So if we have 50 grams, only 39 can dissolve. 11 grams will not. All right, just subtract. So now we're looking at, okay, so if this is what the curve says and this is what we're doing, figure out the difference. So I want to have you guys see if you can go through 9, 10, and 11, and I'll give you a couple minutes. Remember, this is time that you can work through, you can try it, and we're going to go over the answers. So if you don't get it right, you can erase it and fix it. So again, I want you to go through 9, 10, and 11. I'm going to give you 2 minutes or so. Remember that to saturate the solution, you're just getting to the line. A saturated solution means that you're looking at the line. So try 9, 10, and 11. Right? Even if you're not sure, take a guess. Take your best guess. And then we will go over the answers in just a couple minutes. If we look at these questions, I was kind of talking out loud while I was working on them. A couple things. First, if you're like 1 gram difference, that's fine. Notice how for all of these I just did about. If you're within like 1 or 2 grams, that's fine. Just like on an AP test, they usually give you a range. So if you had like 16 grams or 132 grams, that's okay. So for number 9, it says that you're adding KCl at 30 degrees Celsius. So you'll notice that what I did is I went through and I wrote how much can be saturated at that temperature. So at 30 degrees, KCl can have 36 grams dissolved. It says if 15 grams is added, how much more would have to be added to saturate the solution? So you get about 21 grams more. Again, if you had 20 grams instead, that's fine. For number 10, if a saturated solution of KNO3 at 20 degrees is heated to 80. So again, what I did here is I said, here's how much I would have at 20 degrees. Here's how much I would have dissolved if I move it up to 80 degrees. So how much more could be dissolved? Right? How much more means you're taking what you're starting with and just adding to it. So 133 grams more. And then if a saturated solution of KCl at 90 degrees is cooled down, how much will precipitate? So when you cool something down, this is actually how Jello works. Jello is a little bit different because gelatin is has its own set of characteristics. But when you make Jello, you boil the water, right? And you mix in the Jello powder. And then as it cools, it starts to solidify. So that's actually what happens with solubility. If you cool something down, all of that solid that you had dissolved will precipitate out as a solid. So for number 11, what you're doing is you're looking at how much KCl can you dissolve at 90 degrees, how much KCl can you dissolve at 30 degrees. And if it's cooled down from 90 to 30 degrees, some of that will precipitate. And whatever that difference in solubility is will result in a solid precipitating out. Okay, so again, any questions before we go to the next set? Don't see any in the chat. All right, so now we're going to get into some different types of questions. So 12 and 13, notice how we're no longer at 100 grams of water. Now number 12 says, how much NaCl will dissolve in 350 grams of water at 70 degrees Celsius? So I'm going to start by reading the curve. Right, again, I have NaCl at 70 degrees Celsius. So I'm going to read the curve. NaCl, so here's 70 degrees, read the curve. I'll say it's probably 39 grams. So based on the curve, 39 grams of NaCl can be dissolved in 100 grams of H2O. I know this is 100 grams of H2O because that's what the y-axis says. So this wants to know then how much NaCl will be dissolved in 350 grams of water. Now there's a couple ways you can do this. Some people can look at what that factor is. You know, oh, it's 3.5 times as much H2O, so it should be 3.5 times as much NaCl. I like to actually set it up as a proportion just so that people can see the work. So I want to know if 39 grams of NaCl can dissolve in 100 grams of water, how many grams of NaCl can be dissolved in 350 grams of H2O? And then I just set it up like a proportion. So then I can multiply 39 times 350 divided by 100, 136.5 grams. 136.5 grams of NaCl. So again, I'm still using the curve, but then I'm just applying that curve to a different scenario. So then number 13, how much KCl will dissolve in 50 grams of water at 50 degrees Celsius? So KCl at 50 degrees Celsius. So let's look at the curve. So 50 degrees to KCl, let's say 41 grams of KCl in 100 grams of H2O. I want to know how many grams of KCl will dissolve in 50 grams of H2O. And then again, we can go through 41 times 50 divided by 100. Again, for these proportions, I'm solving by cross multiplying and then dividing. I'm just doing it all in my calculator. Again, if you did this more so in your head, that's okay as well. But what I would want to see is that you have the 41 grams of KCl and 100 grams of H2O at least written down somewhere. So that's looking at how to apply what we take on the curve to different set of conditions. I want to look at 14 just really quick because 14, 15, and 16 are similar. So 14 says classify as unsaturated or saturated, a solution that contains 90 grams of KCl and 100 grams of water at 70 degrees Celsius. So now we're back to the 100 grams of water. So now I can just read the curve. So KCl at 70 degrees Celsius. So KCl, 70 degrees Celsius. So here's my KCl line at 70 degrees Celsius. Oops. Okay, here's my KCl line at 70 degrees Celsius. What you're classifying is the set of conditions that they give you. They tell you that this solution contains 90 grams of KCl at 70 degrees Celsius. So I'm going to find 90 grams, 70 degrees Celsius, and I'm going to put a dot on the curve. Now you are comparing this dot to the KCl line. You're comparing that dot to the KCl line. So really this question should say classify as supersaturated, saturated, or unsaturated. So this is where in the notes it talked about looking at the curve. So the line itself represents a saturated solution. So this line of KCl represents the saturated solution. If you have too much solid dissolved at a given temperature, that's supersaturated. So this actually represents a supersaturated solution. This represents supersaturated. If that dot that you drew was under the line, that means you don't have enough solid dissolved, and that's unsaturated. So take a look at 15 and 16. All right, so take a look at 15 and 16. You're looking at KCl at 70 degrees, and then 16 is a little bit different of a question. So take just a minute or so, answer 15. Use all three. Is it unsaturated, saturated, or supersaturated? And then see if you can answer 16 as well. For 15, that's actually slightly supersaturated. It's just above the line. And then 16, what temperature is needed to dissolve twice as much KNO3 as can be dissolved at 30 degrees Celsius in 100 grams of water. So 30 degrees Celsius is about 45 grams. So twice as much as 90 grams. So then we're looking at what temperature will we hit 90 grams of KNO3. And I said about 54 degrees Celsius. So again, we've gone through 1 through 16. Any questions on 1 through 16? Okay, so if not, then we have the second half of this, and I'm going to actually have you guys try this on your own. All right, again, I want you to try it on your own just to make sure that if you have any questions that you get those questions answered. So you have this curve, which is a little bit easier to read. And with this curve, I want you to go through 17 through 26. So when it comes to most and least soluble, you're looking at where everything falls on the curve. Think about the more soluble, the more solid you can dissolve. So the lines that are all the way up here at the top are more soluble versus ones all the way down here at the bottom. So try this. Take about 7 minutes. So you can stay on the Google Meet because I'm going to put the answers up in about 7 minutes. But take 7 minutes. So it's 8:11 at, what would that be, 8:18. We're going to go over the answers to this so I can answer any questions before you guys start working on mastering. So once you think that you're finishing up, I just put the answer key link in the chat, so you can always open that and start checking your answers. I will have them up on the next slide in just 4 minutes or so. Okay, so I put the answers for 17 through 26, and I know it's kind of, you have the first half over here and the second half kind of down here. But you can check answers. So 17 was just reading the curve, which one's least soluble. So you're looking at which of those solids on the curve will have the least amount of solid dissolved at 20 degrees Celsius. 18 and 19 are similar to ones that we've looked at before, where we're changing the amount of water. Least change in solubility is the one with the flattest line, which in the case of this example was NaCl. When you're looking at, is it saturated, unsaturated, or supersaturated, you're looking at the conditions that they give you and you're comparing it to the curve. So since 90 grams of sodium nitrate is underneath the curve for sodium nitrate, it's an unsaturated solution. And then 22 through 26, again, are just asking more questions. So when you're cooling something down, you'll have solid precipitate out. And then 23, the decrease in solubility. So gases tend to show a decreased solubility. So NH3 is the only one that starts high and goes low. And then again, most and least soluble, you're just looking at the curves themselves at that temperature. The higher up the curve, the more solid is dissolved, and so the more soluble that it is. Again, if there are any questions, you can type them into the chat. I put the link to the answers in the chat as well. So now, bell's going to ring in like a minute, but you are going to have an entire period to work on mastering. So you can work on mastering 1 through 16. At that point, some of them are extra credit, but that's about halfway through. So, you know, you'll have a good start if you're working on mastering today. You can also watch video 13. So if instead of mastering, you just want to get the video watched, and then you can work on mastering later in the week, that's up to you. If you want to split up your time, just give yourself about 15 minutes to watch the video. If you pause and take notes, again, it's about 9 minutes. And then you can also work on mastering.